Okay, so interviews in an hour, but just before I do that, I do want to do one more. One actual last one for the order book, even though the question might not come out, but I think it might be a good one to do using a heap. So by looking at the price time priority, our first priority is the price and then the time. I'm first going to talk about the time priority, and I think a good way to implement this is using a queue. A queue is a first in, first out FIFO data structure, so that by using a queue, we can ensure that the first order that comes in will always be fulfilled first, and then we can iterate to the next order, and then the next order, and then the next order. In Python, we can use dequeue, which is a part of the Python standard package, and then this allows for constant time pop left operations in all of one, which is nice and performant. Now for the price point, if we think about it, for a bid and an offer book, we are always only going to be, we will always give the best resting price or the best offer resting price B. For the bid book, we'd always be offering the highest amount of price for a given security, and for the offer book, we'll always be offering up the smallest price for the offer book. And this is good because when we execute a trade, we'll always be executing at the resting price. This incentivizes, and yeah, by doing that, we incentivize aggressors. So this will always benefit aggressors. We incentivize the aggressors to put their highest potential bid. So like I said, for the bid book, we'll always be looking for the highest amount of price possible. And for the offer book, we'll be looking at the minimum. And what strikes out to me right now is that we can use like a binary tree. And one of the trees that might be good for this situation is a heap. For the bid book, we can use a maximum heap where we'll store the highest price point at the very top of the heap. And for the offer book, we'll have the smallest at the top of the heap for a minimum heap. Python uses the heap queue module, which is a part of the standard library, but that offers a minimum heap, so that's fine for the offer book. But for the bid book, what we can do is we can negate these prices when we store it into the heap, and that will make a maximum heap. Just have to be reminded that when we do pop, that we negate the prices again, so that we can actually get the highest number point for a maximum heap. So that's how I'm going to figure out this price time priority. So the price comes from the heap, the highest. And then the last thing is that I'm going to have a dictionary where the key is the price, and then key is the price. And then for the value of this dictionary is going to be a DQ, which is going to be a queue of orders. So what a typical matching might look like is that we'll receive an offer. Let's say let's say the aggressor is an offer. So we'll receive an offer, and then we'll look inside the bid book. We're going to look at the top of the heap, which is the maximum heap, and then we're going to get the price. We're going to compare the prices. If the bid book price is greater than or equal to the offer's price, then a trade will execute. So we're going to access the dictionary. We're going to go to the price. We're going to go to the price key of that, in which there will exist at least one off order, always. We'll have to make sure that the heap and the dictionary are closely linked together. And then for each order, we're going to go through. It might be a single execution, it might be a multiple execution, and then just fulfill those orders. And if an order fully gets fulfilled, we're going to delete it from the price point, from the DQ. We'll pop it from the DQ. And if the DQ is empty for a price, we're going to, for the best price, we're going to pop it from our heap, and then we're going to delete that mapping inside our dictionary. So if that sounds good, let's get going and code. So first thing we're going to do is import the heap queue module from the Python. And then before we actually get into the matching object, I think we need to create some classes. So one class that we need is an order. Let's write the dunder method for this, the init. This is the initializer, not the constructor. It's going to take in self. It's going to take in the direction. So it's just a bid or an offer. That's going to be a string. It's going to take in the security. Now let's write down the person first. So who is related to this offer? Let's find out the security. So which security are they wishing to buy? The price, this is going to be an integer, and the quantity, which is also going to be an integer. And this returns none. And let's just initialize these variables. Price and self.quantity equals quantity. So that sounds good. The next thing is let's also create a trade class. So these are going to record all the trades that have occurred. So when a trade does occur, we're going to create a new trade object. And then for this, we'll initialize it as well. Let's say that the buyer comes first, who bought the security, and then who sold the security. And then the actual security string, the price at which it was bought or sold for, it was traded for, and the quantity, so how many has been traded. And then similarly for this, we're going to initialize all the variables. Cool. Now that we have the order and trade classes defined, we could get on and create our book. The first book that I want to create is the bid book. So let's create the bid book. So def init. The bid book is not going to take any parameters, but what it's going to have is the heap. It's going to have a max heap, which we can just write like this, and then it's going to have a dictionary. Let's call the dictionary a book. The first API that we might add is add order. So let's call it add bid. It's going to take in a bid, which is a type of order. And then it's not going to return anything. Let's say it returns a... But there are no given failure systems for this. I don't think we'll ever fail. So what did we say for the bid? So first we're going to see if... So let's say if a price exists, then we'll simply add it to the book. So let's write some typing. So what does our bid book look like? It's going to be a dictionary, where the first is a integer, and the second part is going to be a DQ. So from typing, import dict DQ. So let's check if this bid price exists in the book. If bid.price not in self.book, then we're going to create a new mapping for this. So self.book bid.price, it's going to be a new DQ. So import that as well. From collections, import DQ. And then we also got to push this into our heap. So heap push. It is heap push. And our heap is going to be the self.max heap. And the value that we're pushing is going to be the bid.price. At this point, we always guarantee that there is going to be, like this has been inserted to the heap and the book. So when we do change the heap, we also need to change the dictionary as well. And simply we can append, well, let's just write it here. So the DQ is going to be a queue of orders. Dot append, we can append the entire bid. Now let's look at our match function itself. And for the match, we'll be taking in an offer, which is going to be a type of order. And let's say it's going to return a list of trades. Actually, it's gonna... no. List of trades as well. So let's have a called executed trades. Cool. Actually, before we do that, we've got a negator here for the maximum heap. So what we need to check is while there actually exists any orders, so while self.book, and if there actually exists some quantity to trade. So while this is greater than 0, we're first going to get the best price possible. So the best price for the bid book is going to be the top of the bit of the heap. Max heap 0. It's going to be the head, and then we got to negate it back. Now we got to check, is this best price, which is the bid price, greater than or equal to the offer price? If it is, at this point we're going to... If it is at this point, then we're going to go through the orders. So let's get our list of orders. List of orders. It's going to be self.book best price. And then we know that this is going to be a DQ order. And then let's say while there is a list of orders, let's access the first order, which is going to be 0. And at this point, we're going to find how much to trade. The amount to trade is going to be the minimum between what's the quantity within this order, and what is the quantity within this offer. Once we've calculated that, we can subtract that from our order, amount to trade, and we can subtract that from our offer quantity as well. And at that point, we can create a new trade object. So the buyer is going to be the order.person, and the seller is going to be the offer.person, the security being, we can get it from anything. I'll get it from the order. And then the price is going to be traded at the best price, and the quantity is going to be the amount to trade, which is the min. Once we've created that, we can append that to our executed trades list. Now, one thing that we need to check here is that because if it's a minimum, either one of the two is always going to be fully fulfilled, or both of them will be fully fulfilled as well. So the first case that we need to look at is, what if this order quantity has been fully fulfilled? So if this quantity is smaller than or equal to 0, it should never be smaller than, but we'll just have a more tighter, stricter checking. Then what we're going to do is we're going to pop left best price from our, we can always pop left from our DQ. Now let's say that there's been multiple executions, or there is only one order for this price point, and that price point has been fully fulfilled, so there's no more orders for this price. At that point, we said that we're going to pop from our heap, and we're also going to delete this key value mapping within our dictionary. So we'll check it after we've done all our list of orders. If not list of orders, so if there exists no more. Let's do that one. Sub.book.price. So if not, if there exists no more orders in the DQ, then what we're going to do is we're going to delete this mapping from our dictionary, and then we're also going to pop heap q.heap pop. We're also going to pop from our maximum heap. Cool. Now this is all when our best price is greater than our offer price. But what if it's not? Then we'll simply just break out of this while loop, as we don't need to do it. But then the thing that if the best price isn't good enough to suffice where a cross trade will happen, then we still need to create a resting offer order for our offer. Or there might be a case where there's been an execution with the top resting bid, but there still are some orders, but there are still some more quantity in the offer that needs to be executed, but the next given price is not good enough. If that's the case, we need to create a new offer. We need to create a new resting offer within the offer book. And then since we can't do it inside the bid book, as the bid book can't see the offer book, we'll have to do it within the step above. So we're going to return the amount of all the executed trades, and we'll also return the offer.quantity. So actually we'll be returning a tuple. I'm going to be returning a tuple where the first is a list of trades and the second is an integer. So that looks good for our bid book. If we do want to have like a cancel operation, what we have to do is we have to give a order ID to each order, and then we have to have a dictionary which matches like which price point does the order exist in. Which price point does the order exist in? And then we can use a DQ, but with a DQ is that we'd have to do an O of N search through the DQ. But we can change this DQ into a dictionary where we're going to map. We can use an order dictionary such that the order that we add stuff into the dictionary will always be kept. And then we can do a constant time operation of popping. Like that seems a bit better. But let's create the offer book. For the offer book, we're going to have a minimum heap. The book will remain the same. For the add bid, we'll be receiving an offer. So offer, there's going to be a min heap. An offer, we're not going to negate it because by default it is a minimum heap. And append it. And for the match, we'll be taking in a bid. So that for here, we'll be looking at the minimum heap, and we don't have to negate it. And then at this point, the bid price needs to be greater than or equal to the best price, and this minimum heap will be popping the smallest price possible. The min is going to be the bid quantity. And then for the trade, we have to switch it around because we said the buyer is going to be the first one, and the buyer is going to be bid.person, and the seller is going to be order.person here. And everything else should be the same, just swatched around like that. So that's pretty good. And then if we get into the matching engine, we'll just create a one thing where it's like, if a bid is coming in but the offer book is empty, create a resting order for the bid, else try to match it and see if there's more remaining stock. If there is, then create a new resting order for the remaining stock and then output the amount of resting trades. So that's an order book using a heap. 13 minutes, wow.